Okay, so this is part 2 of the third lesson on quadratics, which is unit 2. So again, we're looking at when a is negative here. So we are specifically going to start by completing the table of values for the parabola y equals negative x squared. So like I was saying, again, we're just using substitution, right? We have those same x values. We're plugging them into our equation here, okay, in brackets to get our y coordinate. Okay, so negative 4 squared is 16 times negative 1 is negative 16. So that is our first point. We're going to do the same thing with all of these other x values to figure out our coordinates. Again, that double negative is important here. Don't leave it out. Okay, remember, anything times 0 is just going to be 0, so we can always just assume that that's 0 to 0. Okay, notice how important it is to put that in brackets, right? If you typed in negative 2 squared in your calculator, it's going to give you a different answer than 2 squared times negative 1. And if you're ever graphing this and you notice that there's a point way off in the middle of nowhere and it just doesn't really make sense, it's probably because you made an error with one of your calculations here. Okay, not a big deal. Just go back and figure out where that error occurred. Okay, so now we have all of our points. And again, this one is already graphed for us. Okay, so it is this line that we already have. And we can see all of these points on there. So we have 0, 0. We have negative 1, negative 1. We have 1, negative 1. Okay, remember, they're always going to be symmetrical points. We have negative 2, 4, and 2, or sorry, negative 2, negative 4, and 2, negative 4, etc. Okay, so you can find all those points on that parabola. So just like before, we are going to do the same thing. Okay, so we are going to look at a couple different sets of tables here, different equations, which will give us different parabolas. So again, we're just going to look at 2 of them here for the sake of time. So I'm going to cross out these in the middle too. Okay, so again, you're going to need your calculator to figure out these points. So you can definitely turn this negative 1/3 into a decimal if you would like, or you could leave it as a fraction. It's probably going to be easier to use the decimal. So 1 divided by 3, so that's 0.33333, and it's continuous. So it's going to change your answer slightly if you do change that into a decimal, but it's not the end of the world. So again, you would do negative 4 squared first, right, which is going to give us that positive 16 times your negative 0.3333, okay, and it's going to give you a decimal. All right, so because we've already done this, and again, because I don't want you to sit listening to me for hours, I'm going to let you actually fill in those 2 tables on your own, okay? When you do, I'm going to tell you what you should get at the very end. Actually, we'll fill out this last one because there's a whole number there. So again, you're just taking those x coordinates, plugging them in. So here we have negative 4 squared, which is 16 times negative 2. So we have negative 4, negative 32. Negative 3 squared is 9 times negative 2 is negative 18. Negative 2 squared is 4 times negative 2 is negative 8. Negative 1 squared is 1 times negative 2 is negative 2. Again, this is always just going to be 0, 0 for the time being. 1 squared is 1 times negative 2 is negative 2. 2 squared is 4 times negative 2 is negative 8. 3 squared is 9 times negative 2, which is your negative 18. And lastly, 4 squared is 16 times negative 2 is that negative 32. Okay, so again, you would go up and graph these points. So this one, again, our scale isn't quite long enough, so we are going to just do those 5 middle points. So we have negative 2, negative 8. It's going to be there. Well, that should be negative 1. Negative 1, negative 2, 0, 0, and then the same thing on the other side. And we would connect those dots. Again, we have arrows on the end because those parabolas are just going to keep going. Okay, so to summarize, when we're dealing with a as a negative number, if a is less than 1, our parabola is going to open down, okay, which we can see with both of those, right? They open down, they're flipped over, okay, and it's less than 1, so it is compressed. Okay, and that would be all 3 of these graphs that we didn't graph. Okay, they would be compressed, which again means we're standing. Imagine standing in the middle here and just pushing out those 2 sides. Okay, that will give you that compression. Okay, we're almost done. I'm not gonna be able to write, but just listen for a second, and hopefully you can get this down. So when a is negative and a is greater than 1, okay, the parabola is still going to open down, but it's going to be stretched. And I mean, you should hopefully be able to see this on your page. You can't really see it on my video here, unfortunately. We can see that this orange graph is skinnier, right, narrower than that original graph. And the reason for that is because it was stretched. So imagine, again, pulling the ends towards yourself if you were standing at the bottom. Okay, so we have 2 different transformations when a is negative. Okay, so the first is a reflection. Okay, so again, remember that our base graph or our graph in that standard position opens up, right? So in order to state that transformation, when it gets flipped over, we call that a reflection, or flipped is fine. Okay, I'm not too worried about the terminology there. Okay, and then just like before, if we're either compressed or stretched. So if we are compressed, we're going to appear as wide. If we are stretched, we are going to appear as thinner. Okay, so you may need to look at those solutions to just fill in those last boxes if you didn't get them from me verbally here. Okay, so this is the end of the 3rd lesson of Unit 2.